Facebook, be it Wikipedia. There are a bunch of different ways you can go about it.
Actually, I'm going to start with better on your shoulders.
Here you go.
Oh, did you want to start with?
Oh. Yeah.
People definitely had issues on that one.
Yeah, let's go to Ryan's solution.
Is Ryan's solution good?
Yeah, Ryan's solution is a cleaner code.
We did release this, did we? At some point?
I don't know if we released this one. Hold on. Can you guys see that? Okay. So loading data. I think almost everybody in the course got this one, so I'm not particularly worried about it. But basically, you can load from a CSV reader, drop it into array, and cast everything to a float, and then take the last value, ignore the last value, and then grab the last value, cast it to an integer, add it to your Y array, cast everything to stack it. Okay, so homework 3 was it? Is that what we want? Hold on, wait. Homework 3 is due, right? Like,
yeah, homework 3 has been due, but if there are people with like I sent an email to everyone last night. And,
yeah. Are there any people who've still got?
Oh, so apparently one.
Okay, so then let's start with homework 2, and then.
So that idea goes.
Yeah. All right. I'll let you do this.
Yeah, that's why I didn't understand those things. I'm gonna have to step out for a second.
That's on the screen.
Yeah, but then again, it's the baseline, so to be and yada yada. But anyways, with so with that in mind, I guess we'll start with homework 2, part 1, which you guys should remember, hopefully. Now we did already post the code, but we're just kind of going to go through it and see what kind of questions you guys had, because there've been a lot of requests to kind of go back through things. So we start with, in this code, we've got an initializer. This is a kind of standard structure we've been using. You should understand hasAttr is the Python function for telling if something has a given attribute or not. This is kind of part of duck typing, which I don't think we really talked about before, but it's basically in this style of initializer, I don't really care what class the module is, so I don't really worry about whether it's a CNN or a linear layer or whatever. I'm just checking if it has a bias, I'm going to 0 that bias, and if it has a weight, I'm going to Xavier the weight. So this is one possible style of doing initializers where you're just depending on the attributes. The other style would be using something like isInstance to check to see if something is one of a given type of instances. I've seen a lot of code where people are doing things like if the type equals some particular type, and that is actually incorrect. You really want to stick with either duck type with hasAttr or instance checking with isInstance. Any questions on what those do? I guess not. Next function's pretty straightforward. It is the, I guess it's not too straightforward looking through it now. It's got a lot of different stuff in here, but I think that's mostly just because I split out a validation set. And that explains why there's some extra code that you wouldn't normally have. And that's because for this homework in particular, we've just given you the training and the test set, which is the standards one. OK, how many people took less than 2 hours to train their all CNN? Maybe like 1 or 2? OK, more than 5? I'm just shouting out numbers here, like an auctioneer. Or just no one wants to raise their hands today. Let's go forget. Okay, might have some other problems there, but Keras is always fun. Yeah, so just nice to keep that in mind when you guys do your training, because we are trying to get a sense of how long you guys took, but it has been a little while. But anyway, so it chops off all the data sets. This code here, we just have writing the predictions. Should be pretty straightforward to you guys. Basically, just line by line, I'm opening a file. This is your standard file opening in Python. Hopefully you understand that by now. We are then going through the items in the data loader. Keep in mind this is the prediction loader, so the Y doesn't really do anything. It doesn't have anything in it. Putting things onto CUDA if necessary, and then taking the max from the model to actually make the prediction, because the prediction, the model is giving us logits, and the predictions we want to give are the maximum of that logit, and then it's just writing that out. So this is part of the, remember, all CNN. The all CNN training was actually pretty simple, but this is another example of using things like Inferno for doing your training. So I create the module, I apply the initializer, and then make the loaders, which we saw earlier. The save path I'm pulling out from Inferno and checking to see if I've got a saved file. If I do, I load it. If I don't, then I run it. So each of these parameters to the runner should be pretty understandable, but just breaking them down, cross-entropy loss, just like we've always used, that's your standard for most categorical type problems. The metric is categorical errors. That's actually calculating your accuracy and your error that way. I'm saving at every epoch. I'm validating at every epoch. I'm saving it to a given directory. I'm running it for some number of epochs, and I'm logging everything to TensorBoard, which hopefully you guys have at least tried to at least see what you're missing out on.
If the model contains two models, how to add?
What do you mean by two models?
Like listener and speller.
Oh, well, you would have one model which has those two as modules. So modules can be in modules. So in that case, it's a good idea to really break your code down into modules and submodules, and then you just put them together into one larger module. So you have one module which is called like listen, attend, and spell, and that module has two attributes. One is, you know, dot listener, dot spell, or dot encoder, or whatever you want to call it. But as long as you break them out and structure them that way, then it gives your code some sort of organization.
As for the loss function, if we want to add mask because of the homomorphism,
Right.
to use the Inferno.
How to use the Inferno for the mask? You just need to write a custom loss function which takes in the things you need. So you've seen the cross-entropy loss 3D that I've done before? Basically things like that. But instead of just being the 3D cross-entropy loss, which it would be, it should have an input which is the data, an input which is the targets, an input which is the mask. And then you can put those three things together to actually get what you need. The other option is you can slice things out ahead of time in your model and just give it the parts that are relevant, and then you don't need to worry about the mask later. And that's using index slice. So actually, this is worth bringing up just in terms of mask select, just to understand how that kind of thing works. Right, so mask select is one of the useful torch operations, which basically, you've got a byte tensor, which is basically, you know, ones and zeros indicating where you want to include things. And you can take from an arbitrarily shaped array just the items you need. So you could have 100 things in an array, and you could have another array, which is 100 or 97 zeros and 3 ones, and use that to select, and it pulls out just those 3 where it was a 1. So you can use mask select in combination with your mask to pull out just the parts that you care about.
Yeah, so I need to use the mask select to add the true label and the predict label.
No, this would be to just take out the parts that are not padding. So if you have a mask that is showing you where is your not padding, and you run mask select, then you end up with just the stuff that isn't padding, and then you don't have to worry about padding when you do the loss.
Yeah.
So one engineering choice would be to mask select and then just return the stuff that's not behind the mask. You would have to do it on both. You'd have to do the true labels, mask select to ignore the padding stuff, and the other way. And there's actually one other option, which we haven't even really talked about, which is so there are a lot of choices of this. You can do binary masks to try to get things out ahead of time. you can do a mask afterwards, which means you calculate the loss on everything, but you zero out the parts you don't care about. And there's also